The human brain is among the smartest in the world and is able to find solutions to issues that no other species on Earth can. It's also one of the most difficult mysteries that has yet to be solved. It is more powerful than any machine that has ever existed, with over 100 billion neurons. However, there are still some concepts that we find difficult to comprehend. Paradoxes are the most noticeable of all. Although we have evolved to think of reality in a specific manner, there are several paradoxes that suggest reality may not operate as we think it does. We might have encountered several of these odd and perplexing paradoxes while studying physics. What are the most bizarre paradoxes, though? Let's look at the 7 weirdest and most perplexing paradoxes in physics. Number 7. The Fermi Paradox. When you gaze into the darkness of the night sky and the immensity of space, all you can see is our immediate neighborhood and, at best, around 2,500 stars. There are countless billions of galaxies throughout the vastness of the universe. There are billions of planets in each galaxy, which has 200 billion stars on average. This leaves us with 500 billion sun-like stars and 100 billion habitable planets in our universe. It's difficult to fathom a number so large. Life first appeared on Earth about 3.5 billion years ago, after it had originated about 4.5 billion years earlier. Using this, we can make the assumption that there are 100 billion intelligent civilizations in the observable universe, even if just 1% of all Earth-like planets go on to produce life and intelligence. According to this calculation, our galaxy contains 1 billion Earth-like habitable planets and 100,000 possible sentient civilizations. Really startling, no? If there are 100 million billion intelligent civilizations, shouldn't there be an abundance of spacecraft in the universe? All the aliens, where are they? Now that we are aware of the number of worlds and potential advanced civilizations, the question still has to be answered. Why is the cosmos so eerily quiet? This is known as the Fermi Paradox, and nobody knows how to resolve it. All we have about them are conjectures. Given how quickly technology is developing, it's possible that we've already been visited by extraterrestrial civilizations without realizing it. There have been a number of mysterious UFO sightings recently, and some people think extraterrestrials have already landed. If there was strong evidence for such, this dilemma would be resolved. Number 6. The Bootstrap Paradox. A time travel paradox is the Bootstrap Paradox. It's a recurring topic that authors use in a lot of sci-fi books and movies. Dark on Netflix was one such mind-bending program. Let's examine a scenario involving the Bootstrap Paradox. Imagine Albert, a little child who, like you, loves physics a lot and has always wanted to meet Albert Einstein. Now, he works alongside the brightest minds in the world to build a time machine. One night, he sneaks into the lab and uses the time machine to visit Albert Einstein. When he got there, he learned that neither Albert Einstein nor anybody else had ever heard of him. Although he feels bad for him, Albert Einstein's thoughts and equations are all in a notepad that he holds. He writes a book and publishes it under the name Albert Einstein, and hurrah! He gains fame and is referred to as the Albert Einstein ever after. Exactly how is it possible? He would not have been able to pursue a career in science without Albert Einstein, and Albert Einstein would not have ever existed. As a result, a time loop that never ends is created. Our understanding of time is contradicted by the bootstrap conundrum. Events A in the past, B in the present, and C in the future are all products of events A in the past. But in the past, event C was what gave rise to event A. This defies our perception of time and is inconsistent with our theory of time as a linear progression of events. Who actually wrote all of Einstein's equations is the next obvious question. Number 5. The Grandfather Hypothesis. Another time travel dilemma is the Grandfather Paradox. In the Grandfather Paradox, you go back in time to wipe off your grandfather, that is, to make sure he never was. This is only one illustration of how much everyone here loves their grandparents. Once more a time traveler, you go back in time to carry out the mission and destroy your grandfather's memory. Returning to the present, you realize that you never existed because your father was never born, your grandfather is no longer alive, and your grandfather has passed away. Everything about you, including your kin, pals, possessions, and past, has been erased. Thus, this would not be feasible because you would not have been born in the first place. Some experts claim that if this happened, you might have created an alternative chronology or even visited a parallel universe. Would you be there? Or not? Number 4. The cat in the hat contradiction. The Schrodinger'S cat example is a really peculiar one that perhaps all of us have heard of before. This hypothetical scenario was put up by Schrödinger in 1935. In the paradox, a cat is depicted as being imprisoned inside a windowless cage that also houses radioactive material, a Geiger counter, a hammer, and a container of deadly poison. 50% of the radioactive stuff will eventually decay. A poison container that will kill the cat is smashed by a hammer when the Geiger counter detects an emitting radioactive particle. The cat's condition wouldn't be known until the box was opened. Because the cat's fate relies on whether the radioactive material has decayed or not, it would therefore be both alive and dead until the box was opened, or as Schrödinger phrased it, living or dead in equal portions. Until the box is opened, there would be no way to ascertain the cat's condition. The cat would therefore be in a condition that is a superposition of both. The paradox was developed by Schrödinger to illustrate a point in quantum physics relating to the nature of wave particles. Another excellent illustration of this paradox is the double-slit experiment. Number 3. The black hole information paradox. Human thought has been perplexed by black holes ever since their initial discovery. They are best known for engulfing all matter so completely that not even light can escape. But they also provide us with a significant contradiction that general relativity and quantum physics deal with. According to calculations, physical data may disappear forever into a black hole, allowing physical conditions to degrade into one another. This is questionable, though, because according to quantum theory, information can never be destroyed. Let's say you destroyed 2 distinct paper letters. They could still be put back together from ash, it would just be challenging. The 2 distinct letters would remain identifiable even in the presence of minute variations in smoke, temperature, and ash composition. Black holes have the drawback of sucking things in and then, after a very long period, radiating those things back out as Hawking radiation. Hawking radiation contains no information about what the black hole consumed, in contrast to the smoke, temperature, and ash created while burning a letter. This is because all Hawking radiation is identical, suggesting that black holes obliterate knowledge of the cosmos. Therefore, when a black hole dissolves, does the information inside it get destroyed, or does it escape? The quantum extremal surface, an invisible surface that exists inside a black hole's event horizon, has been found by a new group of scientists who say that information does, in fact, escape a black hole via its radiation. This surface changes precisely as expected over the black hole's lifetime if information escapes, suggesting that it encodes the amount of information that has been radiated away from the black hole. Number 2. The simulation paradox. Existence of reality. What if the reality we see is really just a highly sophisticated computer program? Your brain will hurt from all of these simulation argument questions. The idea that we are living in a simulation has been explored in numerous science fiction books and films like The Matrix. Although the concept of living in a simulation has existed for a very long time, it has only recently gained traction after Nick Bostrom of the University of Oxford released a key work on the simulation argument. The idea that our universe is a simulation has been debated by philosophers, physicists, engineers, and, yes, comedians in 2003. Bostrom's vision for a technologically advanced society from 2003 included a lot of processing power, but less than what would be needed to simulate new worlds with intelligent life. His simulation argument showed that, under these conditions, at least one of the trilemma statements must be true. Before humans reach the simulation-savvy stage, they frequently almost go extinct. Second, even if humans do get to that stage, they probably won't be motivated to recreate their own forebears. Finally, the probability that we are within a simulation is very low. Although many scientists disagree and could label this pseudoscience, the simulation argument is generally seen as being highly persuasive. Perhaps the technologically advanced civilization running our simulation is what we refer to as God. What is the simulation argument's right response? In the near future, advanced AI research may determine the solution to this question. Number 1. Combining general relativity and quantum mechanics. This specific conundrum wouldn't have been anything you'd read or heard about very often. The stakes just cannot increase. The challenge of integrating general relativity and quantum mechanics is the biggest challenge in physics to date. This is the issue that physicists have been working on for decades. Two key pillars supporting contemporary physics are general relativity and quantum mechanics. The theory of general relativity describes the world on the biggest possible scales, including black holes, galaxies, neutron stars, etc. It gracefully explains gravity and all it controls, including the dynamics of the expanding universe as a whole, as well as planets circling one another and galaxies colliding. Quantum mechanics, on the other hand, explains the universe on the tiniest scales. The two nuclear forces, as well as electromagnetic, are under its control. When an individual light particle strikes a solar cell or when a uranium atom decays, quantum theory does a decent job of explaining what happens. After many years of research, physicists have empirically verified nearly all of the predictions made by each of these theories with precision that is nearly difficult to achieve. These same theoretical methods do, however, inevitably lead to another unsettling finding: general relativity and quantum mechanics cannot both be true in the current form. The two hypotheses that have supported the astounding advancement in physics over the past century, advancement that has explained the expansion of the cosmos and the basic makeup of matter, are incompatible with one another. This is quite odd. How is it possible for two physics theories to be mutually incompatible? Scientists have attempted to combine these hypotheses for more than 50 years without success. The string theory, which promises to unify both of these fundamental foundations of physics, has been a recent source of hope. The contradiction between general relativity and quantum mechanics is resolved by this new definition of matter at its most fundamental level, according to extensive research by physicists and mathematicians from around the world over the past 10 years. Superstring theory actually explains much more than that. In this new paradigm, the theory needs both quantum mechanics and general relativity to make sense. Despite the fact that string theory is still merely theoretical at this point, it is currently our best hope. Whether it is successful in uniting two of the fundamental rules of physics will be revealed in the future. What do you think of these contradictions, then? Which one do you find to be the strangest? Comment below with your thoughts and let us know what you think. More information about these paradoxes will be released in the future, so be sure to subscribe to our channel and click the bell symbol to stay up to date on any new information.